So now that we explored the print results method and we visualized the various stream elements used to implement that, we showed the actual Java code that was used to define the implementation of print results. Let's turn our attention to a variant that prints what's called a suffix slice, and you'll see what a suffix slice is in a second. And we're going to start out by first visualizing how to do a suffix slice, and then, as we saw before, we'll show the implementation of the suffix slice. This code all appears, of course, in the WordSearcher.java file in the simple search stream example. So what does it mean to do a prefix slice? Or sorry, not a prefix slice, a suffix slice. There's also a prefix slice as well. So print suffix slice is going to take the list of results, which is the results for do, re, mi, fa, sol, la, ti, and so on. And then it's going to take a particular string that corresponds to the word that we want to print from to the end. So what we're going to do is we're going to skip over everything up to this word, and once we find the location where that word appears, we're going to print that set of indices plus anything that comes after it. So in this particular case, if we do print suffix slice la results, we'll just get la and ti and where those particular elements occur. So it's printing a slice of the stream from la to ti while ignoring all the entries or dropping all the entries from do to so. So kind of a funny thing. This will illustrate collect and grouping by again in much the same way we did before. And it'll also give us a chance to introduce the dropWhile aggregate operation. So here's how it works visually. So we have a list of search results as the input, which contain all the search results for everything do, re, mi up to ti. We convert that to a stream. We then go ahead and have a stream of search results. We collect those together into a map. Collect, of course, triggers intermediate operation processing. We have a map of strings to lists. And then we're going to create a group that maps the words with the indices where each word was found. That will then create a map of strings to lists of search results. So far, this is pretty much the same as what we had before. This is where it differs. We're then going to convert the map into the entry set, which is going to be the set of entries we have, which will be the key value pairs, the words and the lists of result objects. And we're going to turn that entry set into a stream. So now we have a stream of entries, which are these string list tuples. And then we're going to go ahead and use the dropWhile aggregate operation. And what that's going to do is it's going to skip over everything that doesn't match the word we're looking for, ignoring them. And when it finally finds a word, it'll stop skipping, it'll stop dropping, and then it'll go ahead and have the results printed out from that point onwards. As we saw earlier when we talked about filter, dropWhile differs from filter since it doesn't examine the entire input stream. It stops once the predicate no longer matches. And the predicate here is basically we're going to keep dropping while the word that is the key in the stream doesn't equal the word that we're looking for. Okay, so we end up at the end with a substream that starts at la, and then we're going to use the forEach method to print the results. This forEach method is actually the forEach method on a stream, not the forEach method on a map. So that's a little different from the previous example. So it'll iterate through all the elements in the stream from the word that we looked up, like la, to the end, printing the results using the same print result method that we saw before. So that's the end of the visualization. We're going to look at the implementation here in just a second. First, however, let me let my dog out of the room. He's starting to whine.